A state space, also called a phase space, is a model used within dynamic systems to capture this change in a system state over time. A state space of a dynamical system is a 2 or possibly 3-dimensional graph in which all possible states of the system are represented, with each possible state of the system corresponding to one unique point in the state space. Now we can model the change in a system state in two ways, as continuous or discrete. Firstly, as continuous, meaning the time intervals between our measurement are negligibly small, making it appear as one long continuum, and this is done through the language of calculus. Calculus and differential equations have formed a key part of the language of modern science since the day of Newton and Leibniz. Differential equations are great when we're dealing with quite few elements. They give us lots of information, but they also become very complicated very quickly. On the other hand, we can measure time as discrete, meaning there is a discernible time interval between each measurement, and we use what are called iterative maps to do this. Iterative maps or iterative functions give us less information but are much simpler and much better suited to deal with very many entities, where feedback is important. Whereas differential equations are central to modern science, iterative maps are central to the study of nonlinear systems and their dynamics, as they allow us to take the output to the previous state of the system and feed it back into the next iteration, thus making them well designed to capture the feedback loops that are characteristic of nonlinear systems.